Hello Kings in Mathematics. So today we are going to see how they solve simultaneous equations using the matrix method. So we are going to see how they solve simultaneous equations using the matrix method. The first step is that you form the matrix form of this equation. The matrix form of this, you write these coefficients before. Make sure this is x and the next that follows is y. So you start with x, which has a 1 in front and a 2. This has a 1, 1. Multiply it with the xy. Don't put over signs. Just write it in matrix equals to. This is 3, 4. So after writing this, look at this matrix here, this 2 by 2 matrix. First thing is to do is to get the determinant. Determinant is got by the major diagonal minus the minor diagonal. The major diagonal is always this, and this is the minor diagonal. So the major diagonal is 1 times 1 minus the minor diagonal, which is 2 times 1, leaving us with 1 minus 2, which leaves us with negative 1. Next thing is to get the adjunct. The adjunct is when you get this equation, this goes up and this comes down, so it becomes a 1, and down here it's a 1. And then if these signs are the same, they will all get negative signs, assuming here. So here the adjunct, remember this is 2, so it's a positive, it will become a negative, and this is 1, it will also become a negative. That is the adjunct. That is for this. In case they were negative, they all become positives. Are we there? In case one of them was a positive and one of them was a negative, they just change the signs. So let's continue here and solve this equation. So we get our inverse. Our inverse is got by 1 over the determinant times the adjunct. So what is 1 over determinant? It is 1 over negative 1 times our adjunct, which is 1, negative 2, negative 1, 1. So what do we remain with? We remain with, this is negative 1 into 1, negative 2, negative 1, 1. So this negative 1 goes on multiplying each value here. Negative 1 times this giving us negative 1. Negative 1 times this giving us now a positive 2. This times this giving us positive 1. Negative 1 times 1 giving us a negative 1. So this inverse, we come and multiply it on each of the following sides of this equation here. Multiply it this side and also multiply it this side, just in this way. Get our inverse, which is negative 1, 2, 1, negative 1. Come and multiply it with this side, 1, 2, 1, 1. This is xy. Come and also multiply the inverse on this other side. Very simple. As long as you get the inverse, everything becomes simple. So remember, when you're multiplying matrix, you multiply this the row times the column. So you get negative 1 times 1 and 1 times 2. Remember, we said row by column. This is 2 times 1 minus, this is, remember, minus 1 times 2. So next one is minus 1 times 1 and 1 plus 1 times 1. Remember, row by column. Then this row by also this second column, which is 2 times 1 minus 1 times 1. Now this minus 1 times this 1. X, Y. We do the same thing here, row by column, which leaves us with, now this is negative 1 times 3 and plus 1 times 4. This is now 2 times 3. This is now minus 1 times 4. So what do we remain with here in the first one? Negative 1 times 1, leaving us with a negative 1. 1 times 2 plus 2. And so here we have 2 times 1, leaving us with a 2. Negative 1 times 2 leaving us with a minus 2. 1 times 1 leaving us with a minus 1. 1 times 1 leaving us with a plus 1. 2 times 1 leaving us with a 2. 1 minus this leaving us with a minus 1. this is xy. Here I'd remain with 1 times 3 leaving us with negative 3, 1 times 4 plus 4, and so 2 times 3 leaving us with 6, negative 1 times 4 leaving us with minus 4. So I'd remain with here negative 1 plus 2 leaving us with a 1, 2 minus 2, 0, 0, 1, xy equals to 3 plus negative 3 plus 4 leaving us with a 1, and this leaving us with a 2. So you should reach, at the moment you reach this point where you get, this is what they call a unit matrix. This is 1 1 and this is 0 0. So at this point you just say, so x will be this value which is 1, and y will be that value which is the down one, which is a 2. Let's try out example 2. Example 2 is 2x, this is x, negative 3y plus 4y, this is equals to 7, this is equals to negative 2. Remember the first step, write this in form of matrix. This is 2, this is 1, this is negative 3, this is 4. Just write these coefficients here. 2, 1, negative 3, 4. Don't just put the 3. Remember I have to put the negative. In case it was a negative, put. Because there's a negative, put. Multiply this by x, this by y. Equate this to 7, negative 3. Remember this x's should be the first and the y's. In case they are not the same, please rearrange it. So we said the first thing is to get our determinant of this matrix. Determinant, we said it is major diagonal, which is 2 times 4, minus minor diagonal, which is 1 times negative 3. What does it leave us with? 2 times 4 is 8, and negative 1 times negative 3 leaving us with plus 3. 8 plus 3 leaves us with 11 as our determinant. So what will now our adjunct be? Our adjunct, remember we said this goes up and this comes down to leave us with 4 up, and this 2 comes down. Now here the signs are different, so they'll interchange the signs. The sign of this negative comes down and this will remain positive. So that means our inverse will be 1 over our determinant, which is 11, times our adjunct, which is 4, negative 1, 3, 2. So I'd remain with as I shall remain with 4 over 11, negative 1 over 11, 3 over 11, 2 over 11. So this inverse that we get, come and multiply it on both sides. That means we shall get now our 4 over 11, negative 1 over 11, 3 over 11, 2 over 11. We multiply it with 2, 1, negative 3, 4, xy, which remember I'm multiplying it on both sides. This is 4 over 11, negative 1 over 11, 3 over 11, 2 over 11, multiply it by 7, negative 2. So we said we multiply this row by this column. So we start 4 times, so the first one now will be 4 times 4 over 11 times 2 plus now 3 over 11 times 1. So negative 1 over 11. This row now times this column is times 2 plus 2 over 11 times 1, row by column. This is what they call a row and this is what they call a column. Then we go to the next one. 4 over 11 times negative 3 plus 3 over 11 times 4, and the next one will be now negative 1 over 11 times 3, negative 3 plus 2 over 11 times 4. Multiply this by x, y. Then this side, what are we having? This side you are having now 4 over, row by column, 4 over 11 times 7 plus 3 over 11 times negative 2 negative 1 over 11 times 7 plus 2 over 11 times negative 2. So we come on, so when we get 4 over 11 times 7 leaves us with 8 over 11. 3 over 11 times 1 plus 3 over 11. This times this leaves us with negative. This leaves us with negative 2 over 11 plus 2 over 11. This leaves us 4 times 3, giving us 12 over 11, but it's a negative, plus 12 over 11. And here I remain with negative 1 times this leaves us with a positive 3 over 11 plus 8 over 11. Multiply here by xy. Here we are having 4 times 7. What do we get? Get 28 over 11 minus, remember this is a minus, 6 over 11. This leaves us with negative 7 over 11 minus 2 over 11. So we work out this the simplified way. 8 plus 3, remember they are the same denominators, so 8 plus 3 giving us with 11 over 11. This is negative and a positive, so it leaves us with a 0. Even this is a negative 12 plus 12, leaving us with a 0. And 3 plus 8, leaving us with 11 over 11. We are multiplying it by xy equals to now negative 28 minus 6. What do we remain with? We remain with 22 over 11. And this is negative 7 now minus 2. So it's like they're adding. So it's like they're adding this. It's like they're adding now these 2 of them. Leaving us with a negative 7, 8, 9. Negative 9 over 11. So what do you remain with here? 11 over 11, leaving you with a 1, 0, 0, 1. I told the moment you reach this unit matrix, you have reached the showers. This is now 28 over 11, which leaves us with 28 over 11, which leaves us with a 2, and this is negative 9 over 11. So our x will be 2 and our y will be negative 9 over 11. Thank you very much.